For number 11 and 12, it says that this is a ABCD is a rectangle. Find the value of x and y. The value of x, all of these are congruent, so they're all 14 each. In the angle, we know that this whole thing is 90, but these two angles are complementary, meaning they add to 90. So I subtract the 82 from 90, and I would get 8. So angle y is 8 degrees. In number 13, FGHI is a parallelogram, and so opposite sides are congruent. So we know that y is 15. Also, when you have consecutive angles, they add up to 180. So 180 minus 135 would give me a total of 45 degrees. So I know that this angle is 45. For number 15, it says find the sum of the interior angles of a hexagon. A hexagon has 6 sides, so that's our n. The formula you're going to use is n minus 2 times 180. Plug the 6 in for n. Work this out to be 4 times 180. So the sum of the interior angle measurements would be 720 degrees if I multiply these together. For number 16, it says find the measure of one interior angle of the hexagon. So you could do this formula again, but you just basically say divided by the number of sides. So we know that the top would be 720. And we're dividing by 6 again, because we have 6 sides in a hexagon. And if I divide that, that gives me 120 degrees. In number 17, given circle O is the center of the circle, find the measure of arc ACB. So you're finding a major arc here. And so the central angle 62 means that arc AB is 62. I would subtract that from 360 to get the remaining major arc here. And that would be 298 degrees. In number 18, if arc measure AD is 100, arc BC is 40, we want to find this angle right here, AED. To find that, you find the average of the arcs by adding them together and dividing by 2. So that would be 70 degrees. In number 19, to find measure of arc AC, first you need to double this angle. It's an intercepted angle. So I want to, it's an inscribed angle. So I double this 38 and I get 76. So the arc right here is 76. I take 360 minus 76 and this gives me 284. So from B to A to C, that's 284. Now if these chords are congruent, that means these arcs are congruent as well. And so if I divide that by 2, getting 142 degrees, each one of those arcs is 142. In number 20, if the measure of arc AE is 100 and the measure of arc BD is 16, find the measure of angle C. So for this one, you actually subtract. You have to subtract the 2 arcs, and then you divide by 2. And then I would get 42 degrees as my angle. And then in 21, the diameter of a circle is 8. Find the area. Use 3.14 for pi. So the area formula is pi r squared. I am given the diameter. So my radius is half of 8, which is 4. I plug that into the formula, and we get 16 pi. But I have to plug in 3.14 for pi, and I get 50.24. Now, in this part of the directions, it doesn't say round to the nearest tenth or the hundredth. but at the very beginning of the test, it did say, show all your work, round your answers to the nearest tenth. So in general, if there's no statement saying what you need to do, then your fallback is to always round to the nearest tenth. So 4 makes the 2 stay the same, and we have 50.2 centimeters squared. For 22, finding the arc length. The arc length is the angle measurement, so this would be 122 over 360 times your circumference, which is 2 pi r, and then r is 3. And so I would multiply the 122 times 2 times 3. I get 732 over 360 times pi. So now I divide by 360. This gives me like 2.03 repeating. So I'm just going to keep that number in the calculator and put times 3.14. And I get 6.38. But again, I'm going to round to the nearest tenth. So 6.4 feet. For the area, so area of a sector, you do the angle measurement again, so 122 divided by 360 times the area formula, so pi times r squared, so 3 squared. I would do 122 times 9 divided by 360, and that gave me 3.05 times pi. So times 3.14, I get 9.577. So the 7 makes the 5 go to a 6. And since this is area, the shaded part that we found the area of, you put feet squared.